Today we have a graph problem given a tree with some nodes. We want to find the deepest path from the root to some children, and then after that you have to answer how many ways you do to color this path. And the second part of the question is just a brain teaser, because if you know the combinatorics, you know that the number of ways is the length of the path, and it's the power of 2. So it's 2 to the power of the path length. And this is the answer. And by looking at the problem acceptance rate, you can guess that the solution is the basic, and you just have to find the trick. And to know the deepest node, you just do depth first search or breadth first search. It doesn't matter, because for this problem it doesn't matter. And we're given the graph in the form of edges from A to B, from one to another. So the first part that we should make is to build the tree itself. And there is one way to do this in hash map. Just scan and attach the nodes in bidirectional order. And after that you use, I used depth first search, and instead of remembering the nodes, I just pass the parent argument to avoid the cycles. And this graph is a tree, meaning that it doesn't have cycles in its data, so I can safely use the parent. And the final step is the computing of the power. You can use, you can't just use the shell operation, because it's out of any long value, because I do modulo operation. So the depth can be 10 to the power of 5. Nothing can prevent that. And I just used fold. It's simple this way. You can use modPow, and I wouldn't describe it in this task because it's out of scope. However, people usually applied it to this solution, but I think it's overkill for this problem. So they almost all of them write this exponent with modulo. But I think this solution is preferable, just fold, and it's fine. By the way, I constructed these nice one-liners to build the graph. You can always use intergroup in a Ether tools in a Rust, and the same for the Kotlin flat map, groupBy, and this is k and this is value, and this is bidirectional flat map of some collection. Okay, that's it for today.